In this video, I'd like to talk about the process of simplifying square roots. So first, let's talk about what is a square root. The square root of an expression is the value that if I multiply that with itself, I get the expression. So if the square root of a happens to equal b, then b times b multiplied with itself will equal a. Now, an important fact about multiplication is that if I multiply a number with itself, if that number is positive, I get a positive result. And if I multiply a negative number, in particular if I multiply the opposite of what I just did with itself, multiplying two negatives gives me a positive as well. And so opposite values like 3 times 3 and negative 3 times negative 3 lead to the same result. Both of them give us positive 9. And so when we think about square roots, specifically when we think about that symbol, the square root symbol, the square root bracket, it's helpful to identify which of these things we are interested in. And what's been decided is that we should end up with the positive value. So this is called the principal root. So if I have the expression square root of 9, that simplifies to positive 3. Again, positive 3 is called the principal root of 9. But in sort of a technical sense, we could also think of negative 3 as a square root. So negative 3 is also a square root, but it's not the square root. It's not what we think of as the principal root. Now, from previous math courses, you probably recall the process of simplifying square roots. If you have something like the square root of 100, we can simplify that to 10, because 10 times 10 is 100. Again, we're talking about the principal root, the positive square root. And looking at something a little more complicated, like the square root of 18, 18 itself is not a perfect square, but I can think about the question, is there a perfect square factor inside 18? And yes, there is. Of course, there's 9, which is 3 times 3. 9 times 2 equals 18. And so I can simplify this in the following way. The square root of 18 is the same as the square root of 9 times 2. But then I can apply the square root to 9, and it becomes 3 times the square root of 2. So I just did a little maneuver here where I took a product that was under a square root, and I rewrote that, or I kind of thought about that as the square root applied to each factor. And so that's an important algebra rule that we can follow with square roots. So the square root of 18 simplifies to 3 times the square root of 2. And let's look at one more example, adding another wrinkle. What if we have negative 5 times the square root of 98? So thinking about that, it might take a moment to realize that 98 is 49 times 2. And 49, of course, is a perfect square, 7 times 7. So I can think of this as negative 5 times the square root of 49 times the square root of 2, which becomes negative 5 times 7 times the square root of 2. And we can simplify that a little bit further by multiplying these two numbers together, the negative 5 and the 7. And so we end up with negative 35 times the square root of 2. So negative 5 times the square root of 98 simplifies to negative 35 times the square root of 2. So let's look back at the ideas that we've seen in this video. One idea is the square root symbol itself. The square root symbol, we've seen, represents the principal root, and by that we mean the positive square root. We've seen that if we have the square root of the product of two things, we can write that as the product of the square root of each factor. And using that property, if we take something like 5 times the square root of 48, we can simplify the square root of 48 and then multiply that with the 5. So 48 is 16 times 3, so we get 5 times the square root of 16 times the square root of 3, which becomes 5 times 4 times the square root of 3, and then multiplying the 5 and the 4 gives me 20 times the square root of 3. I hope you enjoyed the video. Thanks for watching.